My message today is one of hope and regeneration. Right now, many of us are not playing a helpful role in the ecosystems we live in and depend on. We are not even sure how to participate in helpful ways. Let us change that. I will begin with a few steps we can all take towards healing our planet. Then we will consider the importance of communities in restoring our planet to ecological health, and I will discuss some new ways of thinking about ecosystems and communities. So I think you guys probably know most of these, but it really truly is important. Buy organic food whenever you can find it and you can afford it. And that actually includes, I was thinking about this last night, if you can get organic cotton clothes. Buying organic produce protects the people who grow your food. That's who dies from the pesticides and so forth. The planet we live on and our soil. Local, small, and diverse farms are the most effective. Do your best to avoid using pesticides and herbicides in your own home and garden. Don't just spray because you saw a spider. Please don't do that. If you decide you do need chemical help, do the research to find the least toxic alternative. And remember that caterpillars turn into butterflies. If you have a yard, work to improve your soil. Apply compost, plant a diversity of plants, and include some local natives if you can. Leave some bare soil for native ground-dwelling bees. Our native bees, most of them live in the ground, actually. The typical American lawn is an ecological desert, and covering the soil with impermeable pavement of any type is even worse. Ecological desert plus flood, causing flood. Learn about and support regenerative agriculture. This is a way of farming that nurtures healthy soil and as a big bonus, removes carbon from the atmosphere and stores it under our feet. I have included a few resources on the back of the insert that's in your order of service. And you can go down lots of rabbit holes following the YouTubes. Most of the following talk comes from an essay titled Reciprocity by Janine Benyus in All We Can Save, which is an anthology of works by women about solutions for the climate crisis. And she later on she founded the Biomimicry Institute. When Janine Benyus was getting her undergraduate degree in forestry, she was taught that thinning the forest would help the oaks and walnuts that were desired by commercial interests. Reducing competition would provide the commercially valuable trees, like oaks and walnuts, with more water, light, and nutrients. She says, for many in our class, opening up a stand of trees was their favorite part. For me, it was an excruciating empty choice. She goes on to say, I kept envisioning the historic forest right next to ours that hadn't been cut for 200 years. This is on the East Coast. I had seen overstory giants grouped in 2s and 3s and 4s, a middle layer of hardwoods and conifers, and at my feet, trilliums, fiddleheads, and rufous-sided towhees bursting from the duff. Nobody had released these trees from competition, yet all appeared well. The old forest is not nearly as open or regimented as this, I told my professor, but it looks healthier. Do you think the trees might be grouped together for a reason? Do you think they might be benefiting one another in some way? He shook his head no, a bit alarmed. Don't be so Clementsian, he said. You'll never get into grad school. The reference was to Frederick Edward Clements, an ecologist from the early 1900s who had won and then lost the greatest debate in ecological history. Being compared to Clements was a well-known admonition, a sure sign of naivete. It was 1977, and ecologists were 3 decades deep into a paradigm shift that affected our experiments, our narratives about the wild, and most powerfully, our maxims for managing forest lands, ranches, and farms. The precept that trees needed to be released from the struggle of competition was the fruit of a debate between Frederick Clements and his contemporary Henry Gleason. What they both endeavored to describe in very different ways was what constitutes a community of vegetation, what determines how plants grow together and why. When Clements studied bayous, chaparrals, hardwood forests, and prairies, he saw distinct communities of plants reacting not just to soils and climate, but also to one another. He proposed that plants were cooperators as well as competitors, facilitating one another in beneficial ways. Canopy trees nursed the saplings beneath their branches, creating more sheltered, nutritious conditions in a plant-helping plant process dubbed facilitation. They shaded seedlings from the drying sun, blocked the winds, and fertilized the soil with their leaves. As time passed, one community of plants prepared the way for another. Annual plants built the soil for perennial shrubs, and those shrubs nourished saplings that grew into forests. Everywhere Clements looked, he saw communities so tightly interwoven, he called them organismic. Gleason had a different take. What Clements called communities was simply happenstance, random individuals dispersed by chance and arranged according to how they adapted to water, light, and soil. There was no mutual aid. Plants were merely competing for a spot in the struggle. The notion that there might be a connected, interdependent community to be studied as a whole was an illusion. Examining the parts would do. For the first half of the 20th century, this is something I didn't know, Clements' view prevailed. The ecological literature was full of studies on facilitation. Gleason's work was virtually forgotten until 1947, when a small group of researchers resurrected his individualist views and pitted them against Clements' holism. Ecologists in the throes of physics envy liked the fact that Gleason's view of plants allowed individuals to be studied with neat statistical precision, like atoms. It's a lot harder to study something that's complicated. Within 12 short years, Clements' cooperative community theory all but disappeared from the scientific literature, and the majority of ecologists rejected the idea of positive interactions as a driver of community assembly. Graduate students steered clear of the unscientific aura of Clements' ideas and instead focused their research on antagonistic interactions such as competition and predation. Given the times, we shouldn't be surprised. Clements' fall from grace coincided to the year with the release of the Truman Doctrine and the onset of the Cold War. For decades, communism was a third rail best avoided, even when talking about plants. But here is what I love about the scientific method. This is still Janine Benyus, but I agree with her. Though culture seeps into science and sometimes holds its finger on the scale, it cannot stop the relentless search for measurable truth. That's the end of the quote from Janine. So we now have 50 years of research showing that cooperation is a consistent and crucial component in any ecosystem. I will give you two examples. In the foothills of the Sierra Nevada, thousands of acres of blue oaks were being cut down and sold for firewood to reduce competition with the grasses that ranchers needed for their cattle. Ecologist Ray Calloway was doubtful that the oaks were actually harming the grasses. He measured the interaction between oaks and grasslands for 2.5 years. It was his thesis. To quote again from Miss Benyus, his thesis showed that the nutrient totals under oaks were actually 5 to 60 times greater than in open grasslands. Those spreading trees, so artfully arranged in the California landscape, are nutrient pumps that lift minerals from the deep and scatter them in an annual leaf drop. Penetrating taproots loosen the dense soil, increasing water storage beneath the boughs, and welcoming a profusion of plants. Today, experts recommend protecting, not cutting, these islands of fertility. Calloway has gone on to become a leading light in facilitation research. His book, Positive Interactions and Interdependence in Plant Communities, reviews more than 1,000 studies of how plants chaperone and enhance their neighbors' growth, survival, and reproduction. To read these strategies is to discover a manual for how life evolved on a challenging planet and how natural communities heal and overcome adversity, essential reading for a climate-changed world. That's the end of that quote. So my second example comes from the soil beneath our feet. Healthy soil is full of microorganisms, tiny animals like the springtails, as well as fungi and microbes. Perhaps you remember Suzanne Simard, the forester that Reverend Pantea discussed in her tree sermon 2 weeks ago. She is the author of Finding the Mother Tree. Her research showed that fungi in the soil connect dozens of trees, shrubs, and perennials to each other. How do they do this? Fungi produce threads, which I showed in that picture, very thin, long strands called hyphae that snake through the soil from the roots of one plant to the roots of another and then down looking for minerals. This wood wide web allows plants and fungi to exchange nutrients. Fungi can't do photosynthesis, so they need sugars and carbohydrates, but they are good at pulling phosphorus and nitrogen from the soil. Plants provide sugars to the fungi in return for minerals like phosphorus. Ms. Simard discovered that this exchange is wider than just one plant and one fungus. Plants can use this network to share nutrients with each other. They can even share alarm chemicals and defensive compounds. This type of association, where all species involved benefit from the arrangement, is called mutualism. To quote Ms. Benyus again, discoveries about the connected nature of mutualists have vast implications for forestry, conservation, and agriculture in a warming world. Although 80% of all land plants have roots that grow in association with mycorrhizal fungi, 80%. It's rare to find thriving mycorrhizal networks in agricultural fields. End quote. Plowing breaks up these networks, and the constant addition of chemical fertilizers gives the plants a false sense that they no longer need to cooperate with the microbes and fungi in the soil, and they literally shut the connection down. So then the fungi die. As Ms. Benyus says, when communities of vegetation breathe in carbon dioxide, turn it into sugars, and feed it to the microbial networks, the microbial networks, can sequester carbon deep in soils for centuries. But to do that, the communities need to be healthy, diverse, and amply partnered. Does that sound familiar? This is more Miss Benyus, we need to step into the flow of the carbon cycle in new ways. This mutualistic role, this practice of reciprocity, will require a more nuanced understanding of how ecosystems actually work. One of the fallouts of our 50-year focus on competition is that we came to view all organisms as consumers and competitors first, including ourselves. By recognizing at last the ubiquity of sharing and chaperoning, by acknowledging the fact that communal traits are quite natural, we get to see ourselves anew. We can return to our role as nurturers, each a helper among helpers in this planetary story of collaborative healing. End quote. I agree with Janine Benyus. Let us say yes to this new way of looking at ecosystems. Let us return to our natural role as partners in the communities of life on this planet. And let us be grateful that the work we must do with the communities of life in our soil parallels the work we must do in our human communities.